Alrighty then, corn children, children of the corn, it is a fine day for mathematics. We're going to talk about some basic derivatives. Now, hopefully you've seen these. This should not be like your first time through them. It's kind of a reminder thereof. All right, here's our first one. You remember the notation, the derivative with respect to x of a constant. C is a real number. If you take the derivative of a constant, you get 0. That should make sense. If you're graphing y equals c, it's a horizontal line, isn't it? What's the slope of a horizontal line? Oh, that's right, 0. All right, next up. This one's called the scalar rule. K is a number. Once again, we have a real number multiplied by a function of x. When you have a number multiplied by a function of x, you just bring that number along with multiplication and then take the derivative of the x stuff. This is the scalar rule. We're going to do examples. Calm down. Next up, we have the addition and subtraction, the sum and difference rule. Here's the idea. X stuff plus g stuff, other x stuff. X stuff minus other x stuff. If you have adding and subtracting, you can simply take the derivative, and add and subtract. It's like term by term. You just derivative. Easy peasy. And then this one's the fun one. It's the power rule. N is a real number, so like x to the 9th, x to the pi, x to the 3/4, x to a number. The power rule says the exponent comes down in front and the exponent drops by 1. We're going to do some examples. Now what I'd like to do is I'd actually like to put all of these together in one problem. You can do that? Yeah, it's called a polynomial. No way. Yeah, let's take a look. And we're going to use these rules on the following problem. Here we go. All right, pause it, write it down. Here it is. It's a polynomial. Let's see what we have. First of all, we have 1, 2, 3, 4, 5 terms separated by adding and subtracting. According to the sum and difference rule, we can just do the derivative of each part separately, keeping the plus or minus in between. So I'm actually kind of starting my thinking with this rule. We are going to take the derivative. Now notice, this is the function. I now label it f prime. And what we're going to do is take the derivative of this right here, the derivative of this here, and so on, each term down the line. First term. Take a look with me. This is a 3 multiplied by x to the 4th. This is the scalar rule and the power rule. The scalar rule, let's look at that first. Here it is. The scalar rule says when you have a number multiplied by the x stuff, that number just comes along and you multiply it by the derivative. What does that mean? Here's what it means. Here's what it means. You see the 3? Bring it along. There it is. That's your scalar rule. And now we're going to take the derivative of the back part. All right, what about that back part? It's x to a power. X to a power. We're going to use the power rule. So the exponent, 4, comes down, and then the exponent drops by 1. 4 minus 1 is 3. This is the derivative of the first term. Now, corn children, think this through. When you have a scalar and then the power rule, these are going to multiply together, aren't they? Yeah, so check this next one. Here's your negative. I'm going to bring the 3 down and multiply it by the scalar right away. The 5 is going to come along as a scalar, and the power rule will bring it down, so 3 times 5 is 15. Then the exponent goes down by 1. 3 minus 1 is 2. Yeah. All right, this one doesn't have a scalar. I mean, you could say it's an understood 1 there. Next term up, though, the 2 comes down, and the exponent goes down by 1. 2 minus 1 is 1. I'll put it there for you. You're welcome. I know. Next one. All right, negative 17 is our scalar. Here's the deal. We're going to do 1 times the scalar negative 17 and the exponent goes down by 1. What's 1 minus 1? 0. Oh, x to the 0 power. X to the 0 power will equal 1. Yeah, I'll simplify that in the next one. Alrighty, what about this? Well, there is no variable. It is our constant rule, and the derivative of a constant is, I'll write it, is automatically 0. Yeah, so simplifying this up, f prime 12x cubed minus 15x squared plus 2x, here we go, 17x to the 0 is just minus 17, and the constant term is already 0, so we just drop that off, right? I know. Now, it's not only polynomials that we can use these rules. Here's another example. Look how much fun this is going to be, right? Okay, so we have p of t, and it's going to be our job to find p prime of t, the derivative. Nice derivative, yeah. So you might be saying to yourself, well, wait a minute. We don't have a division rule. Well, not yet. No, not yet. We do not have a division rule. So does that mean we can't do this? No, it just means in order to make it fit one of these rules, or two of them, we might have to do a little bit of work. So before we find the derivative, we are going to rewrite the original function. This is not the derivative yet. I'm just rewriting. Rewriting? What do you mean? Can't we rewrite a square root? Well, yes, we can. We can rewrite a square root with an exponent. A fractional exponent. Well, that gets rid of the radical, a 1/2 power, but it's still a denominator. It's still division. Well, can we bring this out of the denominator? Yes, we can. Watch how we rewrite this. 2/3 t to the negative 1/2. Let that sink in. Yeah. There's the 2/3. We bring this out of the denominator with multiplication now and a negative 1/2. Do you see what I see? This is now a scalar, and this is now a power rule. No way. We've gone from we don't know how to do it because we don't have rules for it, and no, don't make up your own, to rewriting it so that it fits the rules that exist. Specifically, we're going to be using the scalar rule, which says just bring that along, and we are going to be using the power rule, x to a power. Even a fraction. Yeah. So here we go. These are all p's. We have not taken a derivative yet. Now I'm going to take the derivative, and it looks like this. Here's the scalar. Bring it along. Power rule. The exponent comes down, and we multiply by it. Then the exponent, and I'll slow down here for you, goes down by 1. So it was negative 1/2. We need to take away 1. Negative 1/2 minus 1. That's negative 3/2, people. All right. So the 2's here reduce. We get negative 1/3 out of that. And we get t to the negative 3/2. Now for the AP test, if you're not going to do anything with this, you can just leave it. But let's remember what this also could look like. There's the negative 1/3. Because of the negative exponent, we can drop it like it's hot. Yeah, that's what I would do. Hope you enjoy that now.